Our galaxy, the Milky Way, is on a slow collision course with its neighbor, the Andromeda galaxy. This illustration shows how the night sky will appear from Earth in about 3.75 billion years. Andromeda, on the left, fills the field of view as it draws near. As Andromeda approaches, its gravitational pull begins to distort the Milky Way. This tidal interaction slowly reshapes our galaxy, creating breathtaking patterns across the sky. Stars and gas clouds from both galaxies interact, forming new structures and a spectacular cosmic display. This grand galactic merger, unfolding over billions of years, offers us a glimpse into the ever-changing beauty and mystery of our universe. Into one of the most crowded places in our Milky Way galaxy, the Arches Cluster. This image reveals the densest known star cluster in the Milky Way, located about 25,000 light-years from Earth in the constellation Sagittarius, the Archer, close to the very heart of our galaxy. The Arches Cluster, along with its neighbor the Quintuplet Cluster, is a relatively young astronomical object, only between 2 and 4 million years old. Yet despite its youth, this cluster is unimaginably dense. In a region with a radius equal to the distance between our Sun and its nearest star, there would be over 100,000 stars packed together. At least 150 stars within the cluster rank among the brightest ever discovered in the Milky Way. These massive stars shine with incredible intensity and burn their fuel at an astonishing rate. On a cosmological timescale, their lifetimes are incredibly short, just a few million years, before they end in spectacular supernova explosions. These massive explosions enrich the surrounding space with heavier elements produced by earlier generations of stars, making the gas between stars unusually rich in material for the next generation of stars. Despite the Arches Cluster's extreme brightness, it cannot be seen with the naked eye. Gigantic clouds of dust in this region completely block visible light, hiding the cluster from ordinary telescopes. To observe it, astronomers rely on detectors that can capture light from the X-ray, infrared, and radio wavelengths, which can penetrate the dense dust clouds. Hubble's recent observations, captured in the infrared, reveal the stunning structure and detail of this cluster, demonstrating just how far the telescope's performance has advanced since its 1999 image of the same object. The Arches Cluster remains a remarkable laboratory for understanding the life and death of massive stars, the dynamics of densely packed stellar systems, and the ongoing evolution of our galaxy. Exploring the Arches Cluster gives us a rare glimpse into the extreme environments where stars are born, live intensely brilliant lives, and die in explosive endings, enriching the cosmos for generations to come. It reminds us of the vast diversity and complexity of our Milky Way and the astonishing power of the stars within it. High above and below the heart of the Milky Way, two enormous structures stretch across space. These are the Fermi bubbles, vast regions glowing in powerful gamma rays discovered by NASA's Fermi Gamma Ray Space Telescope. From end to end, these bubbles extend about 50,000 light-years, nearly half the diameter of our entire galaxy. They span 100 degrees across the sky, from the constellation Virgo to Grus. If rotated into the galaxy's plane, the bubbles would stretch far beyond our solar system. Hints of their edges were first seen in the 1990s, when Germany's rosat satellite detected faint X-rays, shown in blue. Later, Fermi mapped the gamma rays, revealed in magenta, showing that the bubbles extend far beyond the Milky Way's central plane. The exact cause of the Fermi bubbles is still a mystery. Some scientists believe they may be the remnants of a powerful eruption from our galaxy's central black hole, Sagittarius A star, millions of years ago. Others suggest they were formed by energetic star formation near the galactic center. Whatever their origin, the Fermi bubbles remind us of the immense forces shaping our galaxy. Vast, invisible energies that stretch tens of thousands of light-years, hidden until revealed by modern telescopes. Fermi discovers giant gamma-ray bubbles in the Milky Way. Using data from NASA's Fermi Gamma Ray Space Telescope, scientists have recently discovered a gigantic, mysterious structure in our galaxy. This never-before-seen feature looks like a pair of bubbles extending above and below our galaxy's center, but these enormous gamma-ray emitting lobes aren't immediately visible in the Fermi all-sky map. However, by processing the data, a group of scientists was able to bring these unexpected structures into sharp relief. Each lobe is 25,000 light-years tall, and the whole structure may be only a few million years old. Within the bubbles, extremely energetic electrons are interacting with lower energy light to create gamma rays. But right now, no one knows the source of these electrons. Are the bubbles remnants of a massive burst of star formation? Leftovers from an eruption by the supermassive black hole at our galaxy center? Or did these forces work in tandem to produce them? Scientists aren't sure yet, but the more they learn about this amazing structure, the better we'll understand the Milky Way.